Let's be exemplary of good planning ahead right here, because I forgot to set the microphone in place, and that's not going very well. That'll have to do. Yeah, anyway, so this is a Sentec SE-77 and PA-77 component couple. These are really unique stereo pieces, which I believe these were only sold as a kit in Sweden in the 70s. And I've been using these at work as my test stereo for quite a while, a couple of years, and the amplifiers, pair amplifiers, always had a bit of distortion on one channel, making it rather poor for audio test gear use. So I traded with another amp for work, and I brought this thing home. Figured I'll take it apart and try and fix it. It's warranting a real video about it, which I'm going to do at some stage, but today I'm just too tired to get that done. So I figured we'd just take this thing to bits and have a bit of a look inside, because it's really unique. I've never been inside it. And hello chat, 15 people. Good evening, good evening. Wooks, 2x and that guy. Let's just take this thing apart, I think. In fact, I'm not even sure if the issue is with the power amplifier or the preamplifier, because they use this like weird 5-pin DIN setup to connect to each other, and I don't think you can actually run the power amplifier with a normal 5-pin DIN thing, because it has a weird pin out. In fact, I might have been inside one of these at some stage. I don't remember, it would have been so long ago. Let's just start by taking the preamp to pieces and see what we can get. I'm super tired, by the way, so it's not going to be very charismatic of me. But hey, since I'm doing this stuff, why not? I'm feeling inspired by having watched Big Clive for most of the evening. Besides these amps, what's a good amp you would recommend? Yamaha AX590. I might be trading mine away soon. But for Yamaha AX590, I think they go for like $160 on eBay, and they're excellent amplifiers. Oh wow. This is looking way more pro than I thought. Way more pro. Yeah, it's obviously a prefab PCB with which someone's assembled for themselves at home. You know, we have these horrible plastic caps. These always go bad. Wow, this looks way better than I remembered. I don't know, perhaps not remembered, imagined. Because I don't think I've ever been inside this one. Would have been inside a power amplifier. Hello, too bad I have to go. Too bad you have to go indeed. Wow, that looks clean. Well, they have no vents, so it is going to be quite clean inside. Yeah. Oh god. My 27-inch monitor's about to fall off its stand. There we go, crisis averted. Yeah, this thing does look quite clean. I don't think this is going to be in here. We need to disassemble these because I've bodged together the power cord so it runs with a single cord for both devices. Since we have been suffering from a lack of power outlets at work. And the power cords were shit on these anyway. They're rotting. I can't even say that I'm cloning Louis Rossmann this time, since we're not even doing laptop repair. Component level audio device repair. But I don't think I'll be fixing anything on these today. I think I'll just take it apart, have a look, perhaps do a measurement or two. Power amp. I think I've been inside this one. What is your day job? I'm a general purpose electronics, consumer electronics repairman. Or industrial stuff. I fix anything really. Anything at all. If it's got a cord or a battery. How old is it? Early 70s, mid 70s-ish. For those who are just joining us, these devices were never sold as complete products, but they are kits. So some hobbyist has bought this as a kit and assemble it for themselves. And off comes the... Yeah, I recall this. I have been inside this one before. Really nice cases on these. Proper metal. This does look ancient. Issue this one has is the front panel was never properly attached, so it's always coming off. More than once I've snagged the cable around this corner, it's just gone sprawling. So I should fix that at some stage. Oh, the power indicator is clearly broken apart, and we've got a washer and a nut just dangling around in the unit. Let's get another camera going. Hey, crotch cam. We can't get around copying Louis Rossmann around here, can we? Let's see. That works. Let's see what we got. Where am I? You can see we just got a loose nut and washer, like broken neon mount, dangling around in the unit. That's not a good thing. Oh, and the entire amplifier board is not attached to anything. Yeah, I didn't go through this before putting it in use. I just figured out it's lying in the rubbish bin. Does it work? Yes. Put it in use. Oh, what? Okay. Michael Gertzberg, sub to me, give me a shout out. Is that Michael? Let's just get rid of him right away. Go away. In case that's not the actual old Michael, I apologize, but that looked like the real Michael. You will need to change the caps in that, I might. What are those squares for? They're for me to know how I'm aiming the camera. Hey, another live stream, yay indeed. Yeah, there's nothing obviously exploded in here, which would be an obvious cause for the distortion this thing's been putting out on one of the channels. Nothing obvious at all. It's looking quite clean and neat in general, except for the unmounted board. Let's just remedy that. Could just be that it's missing some kind of grounding through that, which would be causing the issue, but I figured we'd try shoving a signal through this thing, if we can manage. I'm not sure if I've got the correct 5-pin DIN adapters at home though. I should probably have thought about that earlier. Yeah, see. I don't think I have the right adapters at hand. Back in a moment. I'll have to dig out some 5-pin DIN adapters so we can power this thing up. Boxes of adapters. Do we have any 5-pin DIN? Well, we've got lots of 5-pin DIN lead. Could do. I'd really like an adapter though. I would really like a 5-pin DIN adapter. But we do not have a 5-pin DIN adapter. So we're just gonna have to butcher that cable. Oh well. Oh well. This is a DIY channel anyway. So let's just do something ourselves. Because that's why we're here. Well, I'm here because I can make some money off of this. I don't think we need that cam anymore. There we go. That's a better view. Hello, I'm late again. Hello there, Vered. You haven't missed much. I just took apart that amplifier you're looking at. I have a preamplifier over there. Whoop content, yes indeed. It is silly how YouTube's rewarding live streaming right now. Because in one of these live streams I did ask for likes. I literally asked for likes, got quite a few likes, and that one live stream is insanely more popular than all the others put together. Good evening, Fackness. Good evening. Party come. No, I do not remember the pinout of the 5-pin DIN. And I don't, there are several standards too, and I don't remember which one this device uses. If I were smart, I would have grabbed the adapters I've been using with this thing all along when I took it home. But I didn't. Because thinking is difficult. What should I do now my PC is dead? Fix it. I slapped a like on this just a second ago. That's good. Keep doing that. It's horrible how literally whoring for likes and comments will actually help you. Now, this is a nice quality cable. They've got a copper sleeve and every signal wire is individually wrapped. That's really nice. These old 5-pin DIN cables tend to be of excellent quality. And the entire 5-pin DIN standard was excellent. You have in and out in the same cable. And you can't get right and wrong, right and left confused. Unless you've made your own cable and done it wrong. So for those who are just joining us, I'm just taking apart a cable right now so that we can test this amplifier. Because it's having some distortion issues. And it's using an obscure, well not very obscure, but old connector, which I don't have a ready adapter for. Well I do actually, but it's installed in my main stereo, and I'm not taking that apart. We've got 4 leads and ground, which is exactly what we want. So this is at least going to have all the leads. Some of the more modern, cheapy 5-pin DIN cables actually just had 2 leads, and they basically bidirectional. They'd only go in one way, or you'd get no signal, or rather signal going the wrong way. Why don't you announce your streams? Because they are impromptu. I don't plan them ahead. I just turn on the camera and go. If I want to plan a video, I make a video. Usually live streams happen when I'm wanting to do something. I think it's kind of worth sharing, but I can't be bothered doing a proper video editing and so forth. You can trace out ground easily, I imagine. Yes, you can. A signal shouldn't be hard to trace either. No. We can actually get around everything. In fact, this the preamplifier has an aux input, and we can just see which cables are connected. No, hang on, it doesn't have an aux input. What am I talking about? It's only got tapes. But the power amplifier should not have no output, so yeah, it's very easy to see on this what's supposed to be input. Very easy indeed. Very easy indeed. So we need to this goes in that way around. Oh, must be fancy. There we go. You can see we've just got two grounded shielded leads coming in there to the input connector, and the outputs are obviously not connected since this is just a power amplifier. So it's pretty damn easy to just beep out what's supposed to go where. Oh yeah, this meter's probably going to be very loud to headphone users. One channel white, the other channel blue. White and blue. That wasn't too hard. That was in fact astoundingly easy. I see the schematic on an SE website. Yeah, I think you can find the schematics online for these. Since they were DIY amps, there's going to be someone putting them on the internet. Blue and white. And the others are NC. So we should really all just... Which lead is suitable for this application? This lead is not very suitable for the application. How will I connect my distortion meter to the input? This is annoying. I don't have any quite suitable cables for this, I don't think. Although we can... let's see. Let's see. In X1 mode, I would imagine this scope probe is just going to be a dead short from end to end. And that'll be a reasonable enough BNC to wire adapter. 300 ohms. Yeah, that's good enough. That's good enough. The ground should probably be a ground unless the probe's broken, which is not impossible. But it's alright. That amplifier looks cute. Yes, it is cute. What? Wait, looked cute. It's still cute. Is Michael still here? Did he get banned? I just banned him again. For ban evasion. Poor sod. Now where is my banana plug to BNC adapter? There it is. It's weird, I only own one of these adapters. I should really get some more. So that can go to there. Let's see if we can get some cameras aimed at the distortion meter while we're at it. Let's see. Oh yes. We are professionals around here. So we just put this to ground and blue and white. There we go. You go over there, right over the noisy laptop. Hairball. Yes, meow. I'm gonna need a power lead for this. Oh, is that another? I think that's another spammer. Let's just get rid of you, Bruno. See, I don't like banning people from the chat, but I don't want it to get spammed with like pure spam. I don't mind ironic spamming, but ever since Michael proved that spamming can be, well, I at first thought Michael was being ironic, but he wasn't, so now I need to keep a more critical eye on the chat, so, you know, be nice, else I might mistakenly ban you, and I probably won't have time to dig through it and unban you, which would be a shame if you're a nice person. This does not at all look very convincing. Is this soldered? That wire was not soldered. I must have assembled that when I was like 12. Wow. Oh well. The things you will find in an old man's workshop. Good work modding the chat. Yes, I clicked several mouse buttons. Alright, let's get connected. Yeah, that's sticky. That is sticky indeed. Good old DIN systems. 2-pin DINs are great. 5-pin DINs are great. I wish DINs never went away. FF, where is that amp made? In some guy's basement. Sentec is a Swedish company, the SE. They only made amplifier kits. So this is a kit someone's bought and assembled themselves. Those are a pain. Contacts wear out really fast in these. No, they don't. What are you talking about? Get quality DINs. These are like 40-year-old 2-pin DINs and they're fine. come on, twisty. Oh wow, this is oxidized. What on earth? Look at how oxidized that is. That's not the lighting. It's actually pitch black. Wow. That's insane. Homemade amplifier. Yeah, it's a kit. Someone assembled at home in the 70s. There's this one. That's black. No, but this one's pretty black as well. We need to arrange these connectors. What's in the syringe? Why are you putting liquid on the connectors? What's in the syringe? What's in the syringe? Why are you putting liquid on the connectors? What's in the syringe? Hey, why do you use a syringe? Why do you put liquid on the connectors? There we go. Gonna take more than just alcohol to clean up the other one though. That one's gonna take some mechanical mongering. Let's just get some of that. Man cleans connectors. Breaking news. It is annoying. It is annoying to clean the two pin-ins between the connectors. I will hand that as a negative, but you don't usually have to do that. Good as new. Good as new. That laptop has a tiny touchpad. Yes, it does. It's a great laptop though. I absolutely love it. Get the fiberglass brush. I prefer not having my fingers full of glass fiber splinters. I have used those glass fiber brushes, but they're okay. But the splinters, man. Seems to be you liking live streaming last days. Yeah, it's because I've been exceedingly lazy. I have a bunch of videos I should edit, I just haven't been bothered. Let's figure out what's ground on these. Because the grounds go together, so if I measure... That's ground. That would be ground. Is that black from the silver plate corrosion? I have no idea. I think it's just like... Well, you know, silver does turn entirely pitch black. So... It could actually be a silver plated contact, but that would be very, very weird. Nothing's better than banana plugs for speaker connection any day. The lack of locking system in a 2-pin DIN made it inferior. There's no locking system on a banana plug. What are you talking about? Alright, let's... Is my webcam in crop mode? I wondered why. That's better. That is wider. Let's connect up to the dummy load. Impressive part about these Sentec amplifiers is they are supposedly fully protected, which was barely heard of in the day. You can supposedly short them out, do whatever. Oh wow, we don't want to have that light on because the... Yeah, look at the needle on the meter when I turn the light on. The tube is just putting up so much noise. It's absolutely putting the distortion meter off. Come on, in you go. I usually have banana plugs and everything, but I don't usually deal with 2-pin DINs, so I haven't had a reason to put banana plugs on these yet. Makes it easier to connect up to the distortion meter though, since the banana plugs are going to be free. That makes it easier to figure out what's wrong. Come on. In you go. Now we just need something to go from the load to the distortion meter. I really like this amp, although it leans sort of like Bang & Olufsen. Yeah, it has a similar look to it, I suppose, kind of. They probably were trying to copy them since it was made in Bang & Olufsen's heyday. Do we have any working? No. I'll just have to use my usual speaker testing box. No, speaker testing, amp testing. This is going to be annoying because we've just got the needle probes on this. But it works. Needle probes are excellent for shoving into various speaker connectors which aren't 2-pin DINs or banana plugs. And normally I would shove these straight into the back of the amplifier in order to get an accurate reading of the damping factor, but we're not interested in the damping factor of this, so having the resistance of the wires, it really doesn't matter. It does not matter. Looks don't tell much, measurements do. Wise words. These amplifiers should perform quite well though. It's pretty low noise. I haven't really thought about it in a performance critical way, since this thing's just, for as long as I've used it, it's just been my test amp at work. So as long as there's been signal passing through it, I haven't really cared. But ever since it started getting distortion-y, that would be annoying. Well, that was annoying. And let's just get the output to the distortion meter as well. In you go. Into the banana plug. Hey, 44 people, welcome. We're just about to power on and test this amplifier, I think. So let's set that to no output signal. Let's measure the input at like 1 volt full scale. So if the needle moves there, that's 1 volt. It's very difficult to shoot this meter since it's so wide. So you see all the settings here and you still need to read the meter face clearly. Oh, we're getting a yellow stream, that's annoying. Oh well, let's see. No input. Output signal is off, speakers are connected. We are not shorting the outputs out. 8 ohms. 8 ohms. So let's also fire up the analog oscilloscope to have a look at the distortion signal. You're not going to see it, but I will. And for that we want a probe. Oh. My analog scope is not connected. This is where you all are going to see my butt. And or watch me fall to my death. Well, that's annoying. Ugh. It is plugged in. Oh, yeah, it is working. Okay. Something's weird with my scope. Please work. A ground. Don't invert B. Trigger. Does this have auto sweep? Where's the trigger level? I haven't used. Oh yeah, there we go. Alright. You can't see shit of what I'm doing, but I'm setting up my analog scope. I just need my probe. Where's my probe? Where is my probe? I had my probe a moment ago. Where's my probe? 47 watching. Yes, indeed. I suppose this is a bit unique. I haven't heard of anyone actually doing amplifier repair live streams before. I wish I could fit everything into the camera. Perhaps we can get the scope in this camera a bit while I'm messing with it. Okay, no, that's not going to work. That's not going to work at all. Not in the slightest. Also have a horrible habit of shorting everything out through the distortion meter since it has rather confusing grounds. There's a times 1. Ground, center, intensity. Intensity, go down. Alright, so I think we want like 1 volt per division. Internal trigger. We want it to be in TV mode, else we'll be triggering on all kinds of horrible high frequency noise. 30 kHz low pass filter. Nothing's catching fire. See, setting this up is such a big mess. But well, let's try and power this thing up. Because I think we will be able to get a signal. We are not tied to ground, that's pointless for the time being. Switch on, power on, no fire. Okay, that was something was not right there, because it was drawing 150 watts and it doesn't usually do that. Have I shorted it out? What are we doing wrong? What happens if I do that? Now it's drawing 6 watts, as it usually does. After googling Sentec PA-77, fifth result is this live stream, lol. Yeah, this is quite an unusual device. This is probably the first video that's ever been on this. Right, but it was drawing 150 watts there, so something's clearly not right. Something was very, very wrong. So I suppose we have just tested the protection circuit. I didn't see if the overload light was shining. I'm not sure. Let's see, did I? Have I goofed this up? The grounds are not together. They stop beeping. 8 ohms. Why was it drawing 150 watts? What happens if we connect one speaker and power it on? I'm not shorting the 2 channels together. Now it's drawing 100 watts. What? What the hell do we have on the output of this? The output of a distortion meter should be off. Yeah, it's set to off. So I don't know why there'd be an awful amount of power coming out of this thing. But let's just put the meter on camera. How about that? There we go. And measure the... There's nothing on that channel. There's nothing on that channel. Have we blown 1,000,000 fuses? I don't think so. Have I just broken this unique and unusual vintage amplifier live on camera? Beep warning. Is that alright, or is it just having a weird... Everything's looking fine. What's going on? I'm doing something wrong. I am clearly doing something wrong, because this amplifier's worked fine in the past. The overload lamp didn't burn. Okay, thank you. Bad output stage. No, this amplifier worked just fine prior to me connecting it up here. Now, there could be a bunch of issues causing this. It could not like the high output impedance of the distortion meter, because that's going to be like 900 ohms. So it could be like oscillating like mad, but more likely is I've just connected something up really weird in this big tangle of wires. Let's just measure what we get on the load when we connect it up. Let's connect up the one we're measuring and drop the probes everywhere. Let's see. Let's make this happen. Oscillation. Yeah, that's relatively possible, but I think it's weird since this amplifiers work just fine every other time I've ever run it. Why would it not work now? There was... what? There's 1 kilohertz at 0.9 volts coming out of that channel. That should not be drawing 100 watts. Is that an issue that's common across both channels? Yes. And now it's stopped drawing power. Let's disconnect the oscilloscope because that sometimes resolves issues. Why did it stop drawing power? You would expect this to draw a couple 100 watts for about 1 second, but it seems to be doing that continuously. Now it's not drawing any power. There was nothing coming out of it, because we melted a fuse. That's weird. Scope it on short time base could be oscillating in megahertz. Yes, it could. But I think that's weird since it's been working so fine when I've tested it otherwise. It would likely be wise to run this thing with the preamplifier. Yeah, we blew a 1.6 amp fuse on a transformer winding there. Yeah, I think I'm just going to connect up with the preamplifier, because I know this thing is kind of peculiar about having the correct preamplifier installed. At some stage I have tried feeding a signal into it just using normal means, but it's never worked. Let's see if we can see that fuse. Come on, focus. Focus, please. That is not going to focus. Okay. Fuse is fucked anyway. Did the heatsink get hot? Wouldn't have time to, not in that short time. I was just using it for a couple of seconds. Let's get a new fuse in there. I should have plenty of replacements. 1 amp. 1.6 amps. This is where there's a giant voltage drop across here now. Nope. Did we burn any other fuses? Beep warning. That's looking fine. Yeah, I'm just gonna connect it up using the preamplifier, because I don't think this amplifier is taking happily to being fed directly from the distortion meter, since we have such a high 8-bit impedance of it from it. And I think this power amplifier has a rather high gain as well. Reminds me of one of those oldish Soviet power amps that destroyed itself when its input was not connected to a powered-on preamp. I've never seen one of those, but that sounds awful. I'm not surprised to hear that there's a Soviet thing doing that though. There are plenty of old Soviet electronics around here. It's fun, you see them every once in a while. I have a Soviet oscilloscope from 1978 lying around. Should do a video on that sometime. So let's... I do not remember which one is the output on this. Let's say that it's the one with the line on. And I'm going to need a new power cord for this as well. Back in a sec. Oh no, hang on. I have a cord right here. How are the few decade-old caps holding on? Well enough. I don't think this thing has many hours on it, actually. But yeah, I'm probably going to replace the caps at some stage. But I don't think the current issue is related to capacitors. Could be, but I don't think so. I realize at the moment I'm just trying to diagnose the bloody thing. And of course that's when it decides to do something it's never done before. Did you already cleaned up your old workshop? I recently watched that video where you let see your room. I have no idea. I've had the same workshop for years. It has not changed recently. It does evolve all the time though. It sees several changes every month. I no longer have a desoldering pump sitting on the bench just off camera to the right, which did free up a fair amount of space. Which means that I can now filter up all kinds of other crap, which is very useful. Alright. Let's just put this underneath. That works. I do believe that goes there. Yes. Alright. So that's the power amplifier, that goes on there. That's the preamplifier, which is goes there. That should be in fine working order. Yep, neon lights. So let's see if the power amplifier is going to draw a stupid amount of power, even with a preamplifier connected. No. It's drawing 4 watts though, which is less than what I think it did before. Are there more fuses to blow? Did we blow the mains fuse? Because I don't think 4 watts is right. What's gone wrong? What has gone wrong? 4 watts is not enough. Am I sure that these fuses are right? That fuse measures 0.35 ohm. That one measures 0.45 ohms. That one's new and it measures 0.3 ohms, and that one measures... Oh, that one wasn't even in properly. That could be a leading cause of issue, and it was fine. Let's try it again. Is this going to explode? It's still drawing 5 watts. Okay. Let's see if we can feed a signal into the preamp and get something out of this thing. Oh, we have a signal. These buttons are very confusing. They're not labeled very clearly. Function. Tape. I think that's right. Volume minimum. Power on. Drawing 4 watts. Will we get output? We will not get output because the signal generator is off. 100 millivolts. Ah, we're getting signal. We are getting signal. So, yeah, the reason the amplifier was drawing 150 watts and blowing fuses while testing earlier was because I wasn't using the specific preamplifier built for it. Which I do recall having experienced before, so that was a bit silly of me. Anyway, let's connect up the other speaker now as well and see if we get any signal on either channel. Then, once we've done that, we can move on to trying to actually measure the distortion of this thing. Now we're progressing, yes. So glad I could make it to your live stream. Glad to have you here. So it's like that Russian one then. Yes, it will explode if not connected to the right preamp. I think it's just the 8-bit impedance of the distortion analyzers too high. Let's use 100 Hz times 10. 1 kHz test signal. Let's be bold. Let's connect up the oscilloscope as well, so that I have an idea of what's going on. This has a tendency of causing horrible ground loops, which give me inaccurate measurements, which makes me all confused and annoyed. Let's tie everything, in fact, to hard to chassis ground. No, let's not, because that's going to make an extra ground loop. Huh. Now that you have a preamp in series, you're gonna measure the combined distortion, which will be worse. Yes, that is entirely true. But the preamplifier should be performing just fine, whereas the power amplifier is performing absolutely horrendously. So we're at 30 millivolts full scale. Let's go to 1 volt full scale. In fact, let's go like 1 volt. Oscillator level 0.8 volts, standard line level, -4 dBu, input level. Right. Now we are pushing power on one channel, pushing... Wow, these are really unbalanced. There's like a 3 decibel gain difference between the channels. That's a lot. So one channel is half as loud as the other, okay? Tone controls off. So that's one issue we need to deal with. Granted, that could be due to the volume potentiometer being close to the bottom. I want to have a better view of a bloody distortion meter, but there's no possible way for me to get that on camera. Aside from cropping it again. Which might give you at least a bit of a better view of the meter. Gotta love the old dual pots. Well, you currently buy dual pots in modern gear as well. Alright. So we're now measuring About 1 volt output. Let's do 1 watt, 2.83 volts per channel. We're drawing 15 watts, nothing's catching fire. 2.5, 2.8, and what? We have very, very little signal on one channel. Like, that's just dumb. Not making a proper connection. Seems we are. Okay, so one channel is barely providing any signal, and my scope is set to ground. I really want to film. Let's just film the scope. That's more visually appealing. Well, that's not visually appealing at all. Man, this is annoying. There we go. That's excellent. So that's the output of one channel. Let's see what the output of the other channel looks like. Oh. That's wrong. That's not a sine wave. That's a pair of titties. We are seeing 1/2 wave. Not even that, 1 part of a half wave. Oh wow. Oops, burned transistor. Yeah, it could be. we are clearly missing missing 1/2 wave and a lot of signal level. Wow. That's silly. Okay. So that's definitely a good way on the diagnosis. Is any of the transistors getting obscenely hot? One channel is cooler than the other. Jeez. Anyway, just out of curiosity, let's see what kind of a distortion level we get on the working channel. So at 1 watt we're getting 0.14% distortion. Oh, that's alright. Let's turn it up a bit more and see exactly. Let's do like 10 watts per channel, 9 volts of output. 9 volts there. Distortion is dropped. Distortion at 10 watts per channel. What's that, 10 watts? It's 10 watts. Is 0.035% on one channel. So that's not bad. That's just fine. It's going to be dominated by noise, I think. Let's see. Let's have a look at the scope. No, that's actually a fair amount of harmonic distortion as well. But yeah, that is definitely dominated by harmonic distortion. How unusual. Usually, it's dominated by noise. Look at the noise while I'm turning the volume up. Let's just see how much power we can get out of this thing. Hoping that the bad channel doesn't explode. Let's see here. 30 volts input range. Let's turn it up to like 1%. That's 1% distortion. And our 8-bit level is, that's not bad, 17.5 volts. 17.5 volts into 8 ohms. It's smelling like old warm ampere. That's almost 40 watts. 40 watts into one channel. That's not bad at all for an amplifier this size. That's quite impressive indeed. Not feeling any great temperature differential between the channels. Let's see. The one that's not functioning is putting at less power, so it should not be running as hot. And that one definitely seems to be running cooler. If it does explode, we're seeing it live. Yes, you are. I would imagine this being the bad channel. We could just be missing an emitter resistor. Let's turn this thing off and measure the emitter resistors, because I think it might be a bad emitter resistor. Let's turn everything off. So, what is our... No voltage in the caps. Minus 2 volts there. Yeah, nothing. Let's measure our emitter resistors. Are they whole? 0.4 ohms. 0.5 ohms. 0.5 ohms. 0.6 ohms. Oh, what a shame. Granted, it could be these resistors over here as well. $11 ohms. Okay, that's not going to be an emitter resistor. Yeah, it's 10 ohms. Specified to 10 ohms. The 8-bit stage consists of tip 34 and 33A. Yes, the 8-bit stage consists of a tip 34 and tip 33A. You are absolutely correct, Pinkorek. Now, there could be any number of things wrong with this thing to cause this behavior. And the annoying part is we can't really test it without the preamplifier attached. Because the fact that it's not exploding and having such a serious issue as if missing an entire half wave of the input signal almost makes me suspect that it might not be the power amplifier after all. Because such issues tend to cause massive explosions, since either it's going to be something shorted on the 8-bit, which causes explosions, or there's going to be some component broken, which makes the input not be equal to the output, which makes the feedback circuit go insane and pull a bunch of current through all the wrong things, causing things to explode. But neither thing is happening. Can you test the 8-bit of a preamp alone? Yes, I can, and yes, I will. That's probably what we should do now. That makes sense. But it's annoying because I need to connect up a scope to that. We don't need a distortion meter since the issue is so glaring and obvious, so let's just do the scope directly on the 8-bit of a preamp. Could be something simple like a shorted diode somewhere. Let's say that our case is a good ground. And let's do one channel, which would be that. Preamp on. And that is looking mighty fine. A bit of weird clipping behavior there. But that's working just fine. Clipping asymmetrically, not really behaving too well. But it's working. It's not missing half the sine wave, that's for certain. That channel's fine. Let's do the other. There we go. Power on. That's looking fine. Behaving exactly the same way. So yeah, I'm pretty certain the preamplifiers doing quite fine. There's nothing wrong with that. What laptop are you using? It has a strange color scheme. It's an old LG. Super expensive, weird LG. According to a schematic, the input impedance is 10k, so it shouldn't be affected by source impedance. Okay. We do have some weirdness going on in the DIN connector, though. There are a couple of pins connected together and so forth. So there could be any number of things weird with the preamplifier. Either way, we know it works that way, and we know that this inputting is fine. So there's clearly something going on in the power amplifier itself. What is going on the other hand, I have no idea. I'm not expecting to solve the issue today, by the way. Just expecting to probe around a bit. I'm way too tired to actually repair anything. Way too tired. So the schematic is hard to read though, they use weird symbols for transistors. Let's Google that. Sentec PA-77. Give me a schematic, I have found that before. Oh, hi-fi engine. Sweet. Oh, they've got the specs written out, let's see. 30 watts per channel spec. Okay, so it's pretty close to that. Construction manual in Swedish. Let's just log in and download that. Now watch the stream break entirely as I'm downloading files while streaming. If it realizes the power transistor problem, then good luck finding a match pair of those old tips. They can be replaced. As long as there is no crossover distortion, then everything is good. Well, technically we don't have any crossover distortion in this case, since we don't have any crossover. You know, just having one half of a sine wave. PA-77 ett helkomplementärt effektslutsteg. This is very Swedish. Give me a schematic. I want to see where the input is going. There's that the entire schematic. That's tiny. Oh wow, those are weird symbols for transistors. What on earth? Where's the input? This is a really weird schematic. So let's... Can we see the power transistors? Where's the output? There's the output, so... The base seems to be the thing that's just going kind of across, whereas the emitter is the part with the arrow. Maybe? That's weird. Input is on the bottom. Yeah, I'm figuring we've got till kanal 2 there. So that can't be, because that's going straight to power rail almost. Oh, is it that? Alright, so the input's going straight into R1. Does that make sense? Then through C1 and into R3. R1, C1. It's a tantalum. Lovely. C3, so... Where's C3? Give me C3. Ah, there's C3. A ceramic. Lovely. So, one end of the C3 should be going straight to ground, whereas the other end should be our signal. So, let's see which end is ground. And if the distortion is present on the other end. Well, whoever said there was a 10k input impedance was absolutely right, because we've got a 10k input impedance there, and the other one's going straight to ground. So let's just measure. It's going to be C3 and C4 to see if we've got our distortion on either of those capacitors. Because if we do, then the issue is... Oh shit, we've got one of those weird ass double transistor thingies there. Oh, those are known for failing. And if the issue is in that one, we should really be seeing the issue on C3, I think. But yeah, those things are awful. Double transistors. Ew. Let's just do C3. Now let's just turn this thing on for starters. Let's not have the volume maxed. Let's make sure we have some output. Let's put 1 watt into our dummy load. 1 watt. In fact, let's see if we actually have an issue present as of yet, because I know it sounded pretty okay. Oh no, I just haven't noticed the issue. So we do have an issue coming out of the output right now. And it's weird, I have been using this amplifier, and this issue has been there for a long time, and I have noticed that it's got some weird distortion, but I've never would have, like, it didn't sound that bad. It didn't sound that bad. It sounded like bad, but listenable. Right, so C3 is looking fine. I'm still not sure which channel the issue is going to be at. Is it that one? That's a big voltage, and it seems to be going both ways. Yeah. So the issue is going to be on this channel. Is it not? Yeah, we've got 1/2 wave coming through that transistor. We've got the same thing on both transistors. Should we not have the entire thing there? Yeah. I'm too tired for power amplifier topology. I am too tired. But it is this channel that's the issue for everyone. To the right, there's a severe lack of grounding points here. What's our signal over C4? That's looking just fine. So I think figuring the issue is probably going to be closer to the 8-bit of input. So, in fact, what we have on the basis for the 8-bit stage? All your bays are belong to me. And that's one of them. That's going to be pre-feedback basically. So that's far weird. So it's clipping, it seems. It's fine for a while, but when it starts doing that, and the other channel's just plain weird. I mean, what the hell is that? That's nowhere near a sine wave. That is nowhere near a sine wave. Let's compare that to the other channels, see what we're supposed to have. There should be pretty much a clean signal, really. Yeah. Clean signal. Clean signal. So we need to work our way backwards from the outputs. What does the chat have to say? Why not just gut the power amp and rebuild both channels around a 5 transistor class 8? No. No, go away. You don't understand vintage audio, go away. Input looks like classic LTP with current source and class A amp. Yeah, looks pretty damn standard, as long as you can figure out the transistors. What do we have on C5? I want to compare C5 to whatever its companion is, because that's in the feedback circuit. C5, where are you? Oh, that's going to be one of those film caps, probably. Yeah, it's going to be unmeasurable. What's R17 then? R17, please. Well, actually, that wouldn't really be much of a point. Now I want to measure C5. I want to measure bloody C5. So I need to find R17. And it's not going to be R17 because this is the other channel, so there's going to be some entirely different number. Where's R17 of the other one? Oh, it's going to be R18. And C6 probably. C6. C5, yeah. Positive side of C5. No, C6. Reveal to us your secrets. That's pretty much what you'd expect. Just the half wave where we're supposed to have that. Yeah. Alright. So what we have on the output of a current mirror thingy. Oh, I'm too tired for this. Is there a link to the circuit? Just Google Sentec PA-77, you'll find it on Hi-Fi Engine. Check D10, D12, R24. What are those? That's gonna be... D10 is gonna be able to short that, yeah, that makes sense. And D12 is able to short it as well. And R24 would be able to kill one half wave, yeah. Those are good points. Thank you for doing my job for me. Grab some coffee. No. And if the right way to go around this is actually to start measuring obvious things like broken diodes and broken resistors before trying to trace the signal, because I haven't even measured the diodes, and I know that these old diodes have a tendency to go sour. Just goes to show that I shouldn't be doing this right now, but we'll give it a go. Let's test all the diodes. That one's fine enough. That one's fine enough. That one's fine enough. That one's fine enough. That D10 there seems to be doing quite alright. Yeah. Well, looking quite alright. I'll shut up if you tell me. No, that's fine. I don't mind you guys doing my work for me. It just makes life easier. I can just sit here being a probe drone for you. And I get to make all the sweet $2 of YouTube ad revenue. Let's just measure around transistors randomly, in case there's a short. Good enough. That's looking weird. That's looking slightly weird. Where's your base? Oh, there's your base. That's going to be 0.6 as well. Yeah, that's good enough. Then you're probably going to be complementary. No. Are you going to be the same? T4? Yes. That's good enough. $2, don't spend it all at once. Yes. I will buy 2 $1 ice cream cones. Someone said R24, that made sense. Let's check R24. That's a resistor. What's that? Low resistance resistor, 100 ohms. That looks quite fine to me. Where else might we want to measure? Which other drive transistors? That's going to be 20 and 18. T18, T20. They're probably the big ass ones that you can't access. Yeah, they're the big ass ones you can't access. We've got D1 and D3 there as well. Did I measure those? Probably. And that's going to be D2 and D4. Where are D2 and D4? There's D2 and D4, and I measured those and they're fine. Let's just keep randomly measuring around transistors. I'm figuring that there's a big likelihood something's just going to be dead short, since we're just seeing one halfway just fall out entirely. We could have bad output stages as well, I suppose. One just not amplifying properly. I don't have any good transistor tester at home though. I really should get one. But hang on, does this have that thing where the drive stage is just basically connected straight to the output? Yeah, it is. So for a quick test, I could just remove the power transistors in order to eliminate those. I'd have to take the board out, but that doesn't look to be too much of a bother. Because if I desolder the power transistors and it starts working, then that would very definitely give us a diagnosis. Are the power rails good? That's a very good question. Let's check that. I should have started. Well, but I just figured, since the other channel's working fine, I'm sure we have power, but there could be a blown trace to one of the transistors, so let's just measure the collectors. Minus 33. 33. Yeah, the power rails are fine. Thanks for the tip though, that was obvious. That was a very good idea. Yeah, I think I'm just gonna take the board out and desolder the transistors. I have no idea how to get this board out, actually. I think it's these screws. Well, 62 people watching. Hello, all 62 of you. You come out as well. As you come. There you go. I think this should be quite service friendly. Couple of slightly short wires there. I'll just desolder the inputs, actually. Let's get rid of this washer before the washer decides to go underneath the board and short everything out and make things explode. Because that would be a bad thing. There we go. So, I need to warm up a soldering station and I need to mark out which wires goes where. Let's put a black blob on the ground. Ground and ground. Solder. solder. I turn the preamplifier off, and I'm going to forget that and be chasing signal with a preamplifier turned off. Out you come. Out. Oh god, that one's horribly deformed, but there we go. They should now fold up quite nicely. Great. This is not bad, isn't it? Do we have any obviously broken solder joints? Well, soldering here is absolutely fine. This is really well soldered together. Really well soldered together. But all solder joints still go bad. This is a lovely looking board though. An absolutely lovely looking board. Yes, all the joints look pretty okay to me. The topology is like the Rank Arena integrated amplifier. I have never heard of that. This looks like a pretty standard Class AB amplifier to me. But I'm no topology nerd. This just looks like all the rest. And now we wait for the desoldering pump to heat up. And move it out of the way so it doesn't solder all my wires. Let's turn the scope off because we're not going to be using that for a while. Warm up. These things take forever. Long way to go on that. Oh well. Let's undo the bolts on these while we're waiting because it's gonna... I'll have to undo these anyway to get the transistors out. Oh, ugh, annoying insulating washers, of course. I hate dealing with insulating washers, they're just a mess. Hi, just got here, what's the problem with the amp? One channel is just putting out half wave. One half of a sine wave, a positive wave, is just falling out, disappearing into the ether. And I'm about to uninstall the power transistors in order to see if the issue goes away. Because I don't have a proper transistor tester at home. And it's very simple to get them out. Smoky. let's also mark out which one of them goes to which side. Else I will forget. White blob there. White blob there. There we go. If I were doing this, I'd just mod them to standard unity gates of the pairs. You're using fancy audio words I've never heard before. The soldering on this board is just so excellent. Absolutely flawless. 10 points out of 10. Transistor. Transistor. Okay, now we are lacking our output stage. So while we're not going to be able to push any kind of real signal out of this, we don't need our speakers anymore. And while we can't push any power with our channel anymore since the outputs are gone, if the issue persists, then we know that there's an issue in the driver stage as well, or pre-driver stage. But we will at least know that these old worn-out tired transistors aren't the only cause of failure. They could still have failed. They could still not work. However, if we get perfect signal now, then there's a very big chance that our transistors have just failed. So let's just power everything on. And now we're going to need the scope again. So let's look at the scope. That's as good as you're going to get. And we're going to need our input signal, because else we will not have a signal to measure. So let's make sure everything's turned off and just solder that in. That's soldered. Zikli is like Darlington, just that the transistors are not the same. Like PN. I have no idea what you're talking about, man. I have no idea. I'm just a humble repair guy. I fix shit. I don't need to know the fancy names for everything. Anyway, we should be seeing our output on, like, yeah, just the emitter resistor should be a good point to measure. Preamp on. Are we getting a signal out of a preamp? Let's just make sure we are, yeah. So this is where there's some weird issue with this amplifier and it starts oscillating and exploding even more on me. No, it's just drawing a bit less power. So, place your bets. Let's not... I'm setting my scope probe on fire. soldering iron. Soldering irons love PVC cables. Okay, place your bets. Are we going to have a good output signal? Yes. That's looking fine. So, I would be inclined to believe that we have bad outputs. It took us a long bloody time to figure that out. A long bloody time. It is incredibly unusual to see bad outputs without horribly exploded fuses or resistors. Wow. So how do these actually look? Do they measure fine? How do our outputs measure? Let's turn this off so I don't put 230 volts in my hands. This is one side. 0.5 volts. 0.5 volts. That one looks fine. This one is the opposite polarity, and it looks fine. Leakage. Nothing which we can see with a multimeter. That is an odd issue. That is an odd issue. Wow. I'm almost skeptical. I'm almost figuring that there's some other issue which is just causing problems when there's current flowing. So they measure fine. How weird. Yeah, granted, there could be just that. Let's see. Well, they don't turn on, but no. Bridge B and C, and the voltage drops. The other one. Yeah, bridge B and C, and the voltage drops. These look just fine. I mean, I don't have a proper transistor tester, so I can't say for certain. But that looks fine to me. Short to case. Now that is a very real possibility. But if there's a short to case, that would be through the heatsink and the collector, since that's the middle pin. And that would just short the power rail to ground. And that would make things go bang and not work at all. And it would certainly not cause us to lose 1/2 of the output. That is weird. What else in the circuit could be causing this? Because I'm very skeptical. I'm skeptical that we've found the issue. There must be some kind of... this circuit is so simple. We've simply removed a gain stage, or rather a current amplifier. That's all we removed. A current amplifier. These transistors are just connected more or less in parallel with the drivers. So there really should be no more magic capable of happening here. It just has to be the case that one of these transistors is simply leaking from base to collector, and is simply shorting out its base current to either supply rail. That's the only plausible explanation I can see. I know shit all about electronics, but try testing them in the opposite polarity. They might have some leakage. Well, I did. There's nothing showing of a multimeter. I'd have to put some voltage on them. Nothing else to do but then measure the drivers. Well, the drivers seem to be working, you know, fine. Since they're pushing a good output to the output. It looked just fine. We could try loading them down a bit with like a resistor. But I'm thinking that there's some weird leakage in these power transistors. Granted, there's a very, 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 very accessible and simple way to test that, and that's to just grab the output from the other channel and move them there. And if... yeah, let's just grab the output from the other channel, because if the outputs... If everything starts working fine then we can say for absolute certain that the outputs are the issue. Let's just do that. Class A or Class B? It's a Class AB, of course. Like all the others. Nothing magical. No audio foolery. Class A amplifiers are absolutely retarded. They are prime bloody audiophile gibberish. I mean, anyone should be able to understand, anyone with the faintest understanding of how transistors work, should be able to gather that more current equals more noise. The more current you have in your amplifier, the more noise it's going to make. But the audiophiles with their Class A amplifiers just go, nah, more current equals better. It adds character. I've had the misfortune of having to repair a few Class A amplifiers in my day. It's just silly. So much oversized componentry for so awful performance. They're just the noisiest pieces of crap ever. Especially those, like, feedbackless designs. Let's make an amplifier and have no feedback in it. Let's embrace the non-linearities in the outputs. Let's have an output impedance of 100 ohms. And the final moo. The soldering quality on this board is staggeringly good. Whoever put this together, if you're out there, guy who built this particular amp, you have my admiration. You have made an excellent effort in putting this together. It is built absolutely flawlessly. Hello FF. Hello Marius. Do you like valve amplifiers? No. They're annoying to deal with and they tend not to work very well. This is where I need to remove the last screw, and now the entire amplifier board is going to come off the heatsink, which is going to be quite annoying. Watch me drop everything and break the board in two. thermal paste, let my transistors go. There we go. This is the part where I mix up the transistors, put them in the wrong polarity and explode everything. But the tip 33 is on the left. So these channels are mirrored. Out you come. Out you come, come on. Out you come. Come on. Good boy. Tip 33 in the middle. Tip 33 in the middle. This is a tip 33, it's going in the middle. Let's not double stack our mica plates. Are these mica insulators? I don't know. They have a weird name in Swedish and I've never thought about them in English. Let's see how we can assemble this. It's quite annoying trying to get this thing together since you need to install the heatsink and the transistors at the same time. Let's see. Let's make this happen. This is exactly the kind of thing you should do when you're really tired. When your motor skills are at the peak of their performance. There we go. That's good. On well enough. Here's the tip 34. Insulator plate comes off. On you go. Give me a bolt. Why do these chip manufacturers put their output power at 10% distortion and why not put the real output power to... They do. You just need to read the datasheet. Just joined. Not sure if you checked the supply rails are good. Is bridge rectifier okay? Yes, everything's fine except for the outputs, I think. There's power supply, one channel is working fine, the other isn't. When I remove the power transistors, the channel started working fine. And now we're just swapping power transistors from the other channel. Because I think we just have some weird issue with the power transistors. Oh god, how the hell is this supposed to go together? I'm now holding this entire amplifier module by one transistor. That's not very good for anything in here. Let's hope the board doesn't break. This board does not deserve to break. It's far too fine quality. I still can't believe that I haven't noticed that one half of the output waveform is just missing. This has been my test amplifier for so long. And I've just gone, huh, that channel sounds a bit weird. Oh well, let's keep using it. This should satisfy all those people who keep asking me for live soldering. I never saw the point of live soldering. But apparently people love it. And Big Clive gets mad views when he does it, so why shouldn't I? You go. Everything's on wonky. You said there was a 10 of them. Replace it. Yeah, I'm gonna probably replace all the caps in this thing in due time. We're just troubleshooting tonight before I get to bed. I'm repairing old Russian audio equipment. Every piece of equipment needs to be recapped. Those Russian caps are the worst things. Recapping solves 99% of problems. The 10 of them could be short. I measured it, it wasn't shorted. Besides, that would not cause 1/2 of the 8-bit waveform to disappear, and it would not account for the return of the 8-bit waveform when we removed the transistors. The fact that the amplifier behaves well with no 8-bit transistors is pretty telling, I would say. And getting that screw in is a lost cause, so I'll just put this one in instead. I want a 1 screw to keep this thing in place. That's good enough. And I put them in the right places. Okay. I already have a scope camera. So I would be willing to wager that this is going to work fine. Preamplifier. Solder in. Let's not turn it on before it's soldered in. Okay. Preamplifier. Enable. Do we have preamplifier signal? We do. Power amplifier. Enable. It hasn't caught fire. Place your bets this is gonna work. And it works just fine. Let's put a small load on that and make sure that it's also able to supply some amount of current. Speaker. Which connectors? Right. Which signal do we wish to measure? We wish to measure that one. So let's turn it on until we get like a watt out of it. No, let's not even do that, because that actually makes a lot of heat in the power transistor, so let's do way under a watt and see if our output's still fine. No! Look at that. The output is not fine as soon as we try and draw some power. That was unexpected. That was unexpected indeed. The tantalum cap C5C6 must always be changed if the power amplifier is broken. Huh. 47 microfarads, 3 volts? Well, that's weird. A shorted C5C6 could cause a high output DC offset, which could explain the issue. I don't think we have any DC offset though. If we would have had a DC offset, my test speakers would have exploded. let's not get 230 volts in my fingers. That would be pointless. No, there's no output DC offset. Even if we disconnect that. No. Output DC offset is 0. Oh, this is annoying. Granted, I want to see if the voltage rail perhaps starts sagging severely when we try and put some power in. So is this right? Yeah, we're seeing some issues. Do we actually have a positive supply rail on the load? Yes, we do. This is annoying. Yeah. I think I'm going to round it off for tonight. I'm too tired to keep thinking about this because I'm just doing whatever you guys tell me to, and that's not the way this channel is supposed to work. So, good night everyone, thank you for watching, cheers.